So, hello everyone, welcome back to my channel. In this video, we will discuss about today's LeetCode Weekly contest 413. So, I will discuss about the approach of each of the questions, and then I will we will code and see the solution. Okay. So first question is okay. Check if the two chessboards have the same color. It is of easy level. So I will explain what is the question, and then you need to discuss about the approach. Okay. So yeah, let's start. So first, a question is, you are given a chessboard. Okay, chessboard have a1 to h1 points, and then 1 to 8, right? Some black and white colors are there. So you will be given two inputs, two strings you will be given, s1 and s2. So these s1 and s2 will be the coordinates of one of the chess. Okay, so here if you see, two coordinates given are a1 and c3, right? So you need to check if the color of a1 and c3 are same. Like if the color of both the coordinates are same, you need to return true, otherwise return false. Okay, so if you see, one very common observation is there. Like if you check, a point is this okay, two coordinates were a1 c3. So the logic behind is, okay, see, this is the chessboard. Okay, this is black in color, this is white in color, this is black in color, and similarly again this is white in color, right? So every pattern repeats after two, you see, here it is white, here it is again white, this is black, this is black, similarly for rows also. So if you check the difference between this, like this is c, this is a, how much difference it is? 2, right? This is 1 and this is 3, how much difference it is? 2. Okay, so if the difference, first we will check this, a means first character, means column. Okay, so c minus a in this case means we are doing s2 of 0 minus s1 of 0, we are getting 2, which is even, right? Similarly for second, 3 minus 1, we are getting again 2, this one. Okay, so if both are even, then the color would be same, and if they both are not even, either one of even and one is odd, then the color would not be same, we would return false. Okay, so this is the simple logic. So here you see, this is the code. First I'm calculating the difference. If the difference is even and the other s2 of other difference is also even, then we are returning true, otherwise returning false. Similarly for the other case, I think this case is not needed. We'll check. Yes, this is also accepting, I think. I was checking that, yes, this is accepting. Okay, I was checking that s1 must be smaller than s2, but that is not the case. Okay, we are taking absolute value anyways, right? So it will not make any difference. Okay, so we will go to the second question. Right. Okay, so second question. Okay, this is of medium difficulty. I will first explain the question and then we will uh, discuss. So B question, it says that you will be given queries. Okay, n queries, there are n queries. What each query will contain? It will contain two values. Okay, let's say 1 comma 2, 3 comma 4, 4 comma 5, right? Now, and you will be given a k one integer, let's say any value 2. Okay, now what you need to do is, after each query, each query means coordinate in a 2D plane. Okay, so you have a very big 2D plane. At after each query 1 comma 2, 1 comma 2, you will insert that coordinate in the plane, and then we'll find out, after each query you need to find, what we need to find out, we need to find the distance from the this, sorry, the distance from the origin. Okay, but the distance will not be, so distance from the origin will be this one, means this coordinate plus this will be the distance of the origin. Means if this point is x comma y, then the distance from origin would be x plus y. Okay, so after each query we need to return the kth nearest number, kth nearest point from origin. Okay. Hope you understood the question. Okay, so you need to return the kth nearest point. First of all, if you are calculating the distance, okay, we will draw here. Okay, we will take the test case 1 2 3 4. Okay, this is the test case. Okay, so first is 1 comma 2. You locate 1 comma 2, so distance 1 comma 2 is inserted. So what is the distance? Its distance is 3, right? 1 plus 2 3. Second, 3 comma 4 is inserted. What is distance? 7. Then 2 comma 3, distance is 5. Fourth is minus 3 comma 0, distance would be 3. Okay, so what, how distance is calculated? Distance is not just sum of the coordinates, it will be absolute value, right? Absolute value of x plus absolute value of y. Some these are positive, but these are negative coordinates, right? If somehow the point is located here, then the distance would be negative, so we need to take the absolute value of this plus this. Okay, now after, so how will our answer look like? Answer will have, if there are k queries, these are k queries, then k answers we need to return. Each of indexes, what it will represent? Kth nearest point, right? So let's say if there are less than k points, we need to return -1, that they mentioned there. No. You see, if there are less than k obstacles, you need to return -1. So approach, like what we can do, the approach is, I will directly jump to solution. Approach is like we will use a heap, or in C++ we use priority queue. Like priority queue of two types, max or min heap. We will use the max heap. Okay, so let's say we have a priority queue named PQ. First query comes, this is priority queue. Okay, at any time, first condition is we will check the size of priority queue. If it is less than k, definitely we need to insert it. No need to check, we need to insert this distance. Okay, because we need to find the kth, we need to find the kth number, and if their numbers are only less than k, then we can't find anything. Okay, so if less than k, we need to insert it. Second, if equal to k, this is the main case. If the size of priority queue is equal, let's say we will check here. Okay, here k is equal to 2, distance is 3, priority queue size is priority queue, one second. So first query comes, size of priority queue is 0, priority queue dot size is 0, so we will just insert it. We will insert it here. Now the size becomes 1. Is the size now if the size of the priority queue is 1, then the kth, second nearest, can we find the second nearest? No, we can't find, because numbers are only 1, so we would insert -1 here in the answer, because numbers are only less than k, right? Then second query comes 3 comma 4. You see 3 comma 4, answer is 7. Okay, priority queue size is now 1, we will insert it. Again less than k, we will insert 7. 7 is inserted here. Okay, now can we find the second? Yes, we can find the second nearest, so it is a max queue. Okay, so 3 is here, 7 is here, so what will be the uh, kth top element? We would always return 7. Okay, 7 is the answer. Now 2 comma 3, 5 comes. Now priority size of priority queue is 2. Okay, now we need to check if the element that we are here, Distance is 5, right? For this, distance is 5. If it is less than the our top element, okay, means we have a candidate, we have a probable candidate that can be the kth smallest, kth nearest integer to the origin, right? So we need to pop out the 7 and then insert our number, correct? Okay, now the top element is 5, so 5 if we insert it. So point is, at any time we need to make the size of the priority queue not greater than k. Okay, suppose if in place of 5 we got 10, then can 10 be the answer? No, we already have, previously we have 7, right? So 10 could not be the answer. We got 5 and 5 is less than this top element 7 of the priority queue, then we, that's why we pop and inserted 5 here. Okay. Let's see test case only, 1 second. Now what comes 3? Okay, we are here. Now again priority queue of size of priority queue is 2. We need to check the top element, right? So now fourth element is minus 1 comma 3, minus 3 comma 0. So distance is 3 again, which is less than priority queue dot top, right? So we need to pop this 5 out and insert 3 there. Now the top element is 3, 3. So this is our answer. Okay, this is the approach. And okay, you can see the code here also. Yes, okay. So you see here I am declaring this priority queue. Now we are here, I am calculating the distance. This distance I am calculating. Now if the size of priority queue is less than k, we don't have any other option when you only need to insert it. Okay, but if it is greater than, greater will not be there, if it is equal to k, then we need to check whether it's, if the new distance is less than the top element, then we need to pop the rest and push the new element. Okay, and after these operations, if any time the size of k priority queue is less than k, then we need to insert -1, other than, otherwise the answer would be priority queue dot top. Submit. Okay, it is submitted, right? Now we will go to the third question. So this is of hard level. This is a good question. Okay, so I will explain the question first, then we will, first we will describe the intuition behind it, and then we will discuss the solution. Okay. Okay, select cells with the maximum score. I will, let's copy this test case, then we will discuss. 1 2 3. Okay. See question. So you are given this matrix. Matrix is 1 2 3 4 3 2 1 1 1. Okay. Now let's okay. These are indexes 0 1 2 0 1 2. We need to calculate one value. Let's say its answer. We need to return this such that at each step from each row we can choose only one value. Two conditions are there. If you see the question, two conditions are there. No two, we need to select cell from this matrix so that no two selected cells are in the same row and each value must be unique. Okay, like yeah. In the zeroth row we have, for the zeroth row we have three options. Either we can select 1, select 2, select 3. Okay, again in the first row we have three options, 4 3 2. And second row, last row, we have three options, 1 1 1. So at each step, either from these three values we can select only one. From these three values only select one value. From these three only one. At the end we need to find the sum of the selected values and return the maximum one. Okay, like what will be the cases? uh, you select 1 here, select 4 here, select 1 here, or might be select 2 here, 4 here, 1 here. Understood? So the brute force we can think of is uh, we select maximum at each select. We select 3 from here, 4 from here, 1 from here, 4, 5, 6, 7, 8, 8. Okay, this is correct. But where it will fail is it will fail in the second test case, I think. Okay, you see 8 is the answer for first one. Okay, now let's look at second. 876, 832. So the second test case 876, 832. You find the maximum from this row, you selected 8. Then you find maximum from this row, you selected 3. What is the 11 is the answer. But this is wrong. The correct answer is you should have selected 7 from here and 8 from here. Then the answer would be 15, right? So selecting maximum from each row is definitely wrong. So now what we can think? One solution is we will use recursion, but okay, okay, you have a matrix. You have 0 to n rows, 0 to m columns. Okay. So recursion is for each row you can what you can do, you can select either this, either this, either this, right? So for each ith row you have how many options? You have m options of selecting the number. Okay, so if you write a function I is the row, right? And then you check okay, and then you will pass the grid, which is this matrix, and leave it. Only main thing you check, this is ith row, and this we are passing vector. Let's say second, you are at each row you are selecting one of the values, and then you are incrementally going to second row, third row. Each of the row you are iterating, and you are collecting the numbers which you are getting, right? I will explain. Let's say this is 1 2 3 4 5 6 7 8 9. You come here, okay, you pick up one, okay, you inserted one in your basket. Now you can't select any other number from this row. You go to second row, you inserted, let's say, 5 from this, 5 in your bucket. Okay, then you come to last row, you inserted, let's say, 9 in your bucket. Okay, now whenever this bucket size is n, you return that this is of the all the possibilities you need to check here. Okay, now if you write a function which I if you're an ith row and you are given a vector, okay, this, let's say, this is the array. This will include up to ith row how many numbers you have. Let's say if your ith is second, so in 2 rows which numbers you have selected. Okay, so for this, for each row you will iterate from j equal to 0 to j less than m j plus plus. Like you are on ith row. Ith row you can select any of the m elements in the in its row. Okay, correct. Now what you need to do, you need to return maximum. Like you need to return, either you will include this element or you don't include it, right? So if you included it, what you need to return? You need to return the maximum of the values chosen, right? So j equal to 0 to m, you are iterating. Now what you will get, you will return maximum of, let's say your variable was answer, then answer comma function. You will go to next row, include this element, means you included the grid ij element, right? Something this kind of logic. So this logic I will explain, but this was getting TLE. Okay, I will show TLE. You see this code, this I submitted, but this was getting TLE. So new approach using bit masking we will discuss here. Okay, we are initializing this array. this function means 0 0th is the current row. Current means the current sum that we are getting, like current array, like up to ith row how many elements we have chosen. Okay, and this is the answer. So we go to here. If I equal to n, leave this condition, we will check afterwards. We check this. Okay, for each row we are iterating each of its elements, we are inserting the element, then going to next iteration, and then removing that element. Okay, from backtracking we are using. So if I equal to n, we also need to check the numbers that we inserted in this current vector all needs to be unique. So this logic is there, that is finding the unique elements and doing the sum. Okay, and then answer is equal to maximum answer, and we are getting the maximum answer here. Okay, but this is getting tally. Okay, because the complexity of this is high, right? The value of n was given, what was the value? N is 10, right? So means for each row maximum can be 10 rows and 10 columns. So for each row you are getting, I'll explain here, there are 10 rows and 10 columns, like n equal to 10 and m is also equal to 10. So for each row you are doing this one, right? So complexity is high here. What is the complexity? If 10 rows are there, for each row means n to the power n complexity is there, because for each row 10 n rows are there, and for each row you are doing this recursive call, right? So you are on ith row calls this n times. If 10 rows there, then each row will be calling 10 times, right? So this is very high complexity, means 10 to power 10, this will be TLE. Okay, so now the better approach, what is better approach, we will discuss. Okay, so we will use the test case, like here our test case was failing na previous approach, so we will use this one only. Like we have 8 7 6 8 3 2. 0 1 0 1 2. Okay, the numbers, one constant is the numbers are only 100, right? So means value of numbers less than equal to 100 is ai, this one. Okay, first we need to, here approach is we need to store the index of each of the elements. Let's say numbers can be 1 to 100 only, right? Here let's say 8 is there. 8 is present at which indexes? 0 comma 0, right? Then 1 comma 0. 7 is present at which index? 0 comma 1. 2 is present at which index? 0 comma 2. Okay, similarly others. Okay, so we will use a map, any data structure, such that we will find the index of each element wherever it is present. Okay, so actually this j is also not needed. Okay, but we will, okay, we are getting this. Now if we iterate on this, how we will iterate, I will explain. But if we iterate like these indexes, sum of these values 0 0, this is count of this, can it be greater than 100 or n cross n? No, right? It max value will be 100 only, because these are the indexes, only rows na, 10 cross 10 matrix is there, the maximum value will be 100. So we need to think in this area, like how we can use this approach, how you can use this information that maximum these indexes are 100, and if we know that our, let's say 8 is present at this index only, then can we use this information? Okay, so let's say you have this data, 8 is stored at this index, 7 is here, 2 is here. Okay, now what you need to do is, first you need to sort these values depending on the index. Here it is sorted 8 7 2. So you have a data structure which stores let's say some value a1 is present at this indexes. We don't need a pair here, we don't need a pair, we only need to know this particular number is present at which row. 8th is Like 8th is present at 0th row, first row. 7th is present at 0th row. Only this information we need. Okay, because why? Because the numbers selected from the rows must be unique. Right? Here the condition is no two selected cells in the same row of the matrix. Okay, so suppose we have this kind of information, like a1 is present at i1, i2, i3, these rows. a2 is present at some indexes, a3 is present at some rows. We need to sort these values in descending order, like a1 must be greater than a2, must be greater than a3. Okay, we did this. So for this example, 8 present at 0 index, 1 index, 7 is present at 0 index, 6 is present at 0 row. Okay, 3 is present at first row, 2 is present at first row. Okay, now one thing more we need to use is bit masking. So the this question is of this plus bit mask. Okay, how we are using bit masking, we'll explain. Okay, now now previously you were iterating on the row, right? Here here this is this index. What was this? This is the rowth index. This one, right? Now we will iterate. Now we will not iterate on the row. These are the rows. We will iterate on the values, and we have sorted in descending order, right? So these are the values. We will iterate. For each iteration, we will check which rows it is present, and if that row has been included, like we go to 8 here, we check 0. Is 0 included in our row? It is first entry, right? We have, let's say, a row, an array of row. This is empty. We go to here, we check 8 is present at 0 and 1. We can take any one. Let's say we take 0. We will check. We will check here. If 0 is present here, no, right? So we can insert 0 here, okay, and then include 8 to our answer. Then we will go to 7. So we will check 0 is present in the row. Yes, it is present. We can't include 7. Can't include 6. 3 we can include. 2 we can include. 3 we can include. 2 we can. 2 we can't include. Okay. Okay. Now here again we are creating a row. So therefore we are again increasing the complexity. What we will use is, we will use a bit mask of row. Let's say we name it as row mask. Okay, let's say it is a n size, 0 1 2 n minus 1. So if the ith bit of this row mask is 1, it means that this row is being included in the previous answers. Okay, so instead of taking this row, if we have taken row mask, so initially row is 0, we would check, okay, 8th 0. Okay, is the 0th bit, let me explain here. Okay, suppose this is not present. Okay, is 8 is present at 0th bit. We will check, is the 0th bit in row mask 1? No, right? 0. Then we can include this and we'll set this bit. This bit is set. We have included 8 to our answer. We will go to 7, right? Is 0, this is 0. Is 0th bit included? Yes, it is being included here. We can't take 7. Okay, similarly the process is same, but instead of taking this row, we are taking a row mask, in which if the ith bit of row is included, if the ith bit of row mask is set, it means that this row has been included in the answer and we don't need to include in the future calculations. Okay, so we will do a iteration. I will show you code, then you will need better understand. Okay, okay. Hmm. We have created a map. So what map is doing? Map is doing this thing, right? This logic, this one, that this number is presented which index, this is presented which index. Index means which row. This is number is presented which rows. Okay, so this is done. Now we are using this function. Okay. This value is the value, means we, instead of iterating on the index row numbers, we are iterating on the values. Like maximum is 100. Okay, so we will start from 100. We will check if 100 can somehow we include this 100 to our answer. Okay, like somehow if 100 was present here, okay, then we would have checked if 100 is present at which rows. Okay, if it is not present, then we would not include. First we will check for 100, then we will check for 99, 98, similarly for 0. Okay, so the base case you check here if is 0. If 0, then we return. We start from 100 from maximum, and then we get down to the 0. Okay, now what we are doing, we are taking a new variable row mask that we discussed here. Row mask, what it contains, if the ith bit of this row mask is 1, means we can't include the current element. Okay, so we are taking this result. Okay, this condition is important. This is what we are iterating. Let's say we got a number. Okay, we got a number here. Okay, this check here, 8 is presented, 0 and 1. We are iterating on this. We are getting the row number. Yes, okay, so first we are getting 0, then we are getting 1, then we are checking if 0 is set in the row mask. So this is a bitwise operation. Bitwise we are checking this. So this condition checks if the row number bit, okay, is set in the row mask, then we don't need to do anything. We only need to include it when it is not set. If this is 0, then we would iterate again, then we would proceed forward. This means not set, so we need to include that number. How we are including? Here you see this num, okay, and here we are including the number. Okay, then we need to do or, means okay, explain. First we check whether the 0 is present in the row mask or not. How we check? One left shift. I will explain some bitwise also. Okay, let's say you have numbers n, and you need to check if the ith bit is 1 set. How you check? If n and one left shift of I is not equal to 0, this means ith bit is 1, right? These are some conditions. Okay, and similarly if you are looking at this condition, what this means? Okay, this means you have included 0. Now this bit needs to be set. You have included the 0th row. Now the 0th bit of the row mask should be 1, so that other element can't be included from that row. How you set it? You take the or, like here we check na, if the ith bit is 1. If you need to set ith bit to 1 in n, how you can do? N or 1 left shift I, right? This would set the ith bit in n to 1. Similarly we are doing here. We are setting the this row number bit to in row mask to 1. Okay, and this memoization is I added this TP of number and row mask. So number can be 100. Maximum we are iterating on values now from 100 to 0, so this can be 100. And there, so what, 1025. Second, why I included 1025? Because this row mask, what is the what can be the maximum value of row mask? You see, grid length is 100. Maximum number of rows can be 10. If the maximum number of rows are 10, then you need 10 bits, right? If you need 10 bits, maximum number of rows are 10, so you need how many bits? 10. You need 10 bits, right? 0 to 9, 10 bits to determine whether the ith bit is set or not. So what would be the maximum value of this number? 2 to the power 10, 1024, right? That's why I included 1025, right? So hope you understood the question. So this was a hard level. This is a good question. So if you have any doubts, please ping me in the comments. I will describe the solution more appropriately. Okay, so please guys do subscribe and like my videos. It gives me the motivation to create more videos again. Okay, thank you.